Hi everyone. So actually I just want to talk about something before we start the presentation. So as a backup speaker, there's another guy who is here. He's not here, obviously, because I'm here. But this is the content slide from his talk. So if you are looking for the ZOS stuff, please contact him. He really did a lot of work. He got accepted. He deserves the credit for it. So you can just reach out to him on his Twitter handle at the bottom here, or follow him on GitHub. So he wrote three things that will basically help when you're looking at the mainframe stuff. So if you're looking for that, you can follow this slide. Okay, so we're going to actually do like a bunch of stuff. I know the intro is like about Maltego, but really we're going to be looking at more interesting things, and I'm going to be using Maltego just to do the correlation and finding it. So I'm going to do a little bit of an intro, like who I am, boring stuff, then how to do footprinting in like 10 seconds, and then we'll start looking at interesting things. So I'm going to try being, the first section being hunting ICS devices. So if you're looking to find power systems on the internet, how would we find them, or water, or whatever else? And we'll start by saying, okay, well, first we want to look at maybe something that I have context on. So I'm looking for like Nevada Energy or something, and then we'll move to saying, okay, well, if I want to look at an entire country's power system, how would I look at that? The second section, we'll look at interesting people. So the first section kind of like interesting places. And that will be like looking at how to use those, all the different breaches that have happened to say, okay, well, using footprinting and networking side, I can track people from interesting organizations and find information about them outside of their organization. And then the last one, just looking at interesting locations and individuals who work there. And then questions if there are any, and then beer. So that's the agenda for today. So a little bit about myself. My name is Andrew Macpherson. My alias is Andrew Mohawk. I've been working at Patova for 10 years. My employee number has all those zeros in case we hire 1 million people, then I'll still be number one. And I have an information science degree from 2006. So also for DEF CON and Black Hat, I dyed my hair white, which has gone really well with my friends. So they just comment that I look like Draco all the time. It's great. And then of course, like there's an analogy that anyone who has a hammer, everything looks like a nail. So to me, I mean, I work at Patova, I build a lot of stuff in Maltego. I'll basically try and automate everything with it. So I'm that guy just with a Maltego hammer. Okay, then I was meant to co-present with Temmingh. So he's the co-founder of SensePost. He's not here because we couldn't move his flights in time. But he started SensePost in 2007 when I started there. He's the MD, he does stuff. And he's done a lot of talks. So he's really confident, not standing next to me though. Okay, so the first section is generally I'd say like, what is Maltego? What does it do? If you don't know, we've got loads of video tutorials and you'll just see me using it during the presentation. So you'll have an idea of roughly, you know, what it can do. And then you can just follow those if you want to figure out more about the tool. So there's a heck of a lot of demos. Well, it's not a lot, but it'll be like a constant demo basically as we move through the pieces. But all my demos rely on a stable internet connection, which they told me I can use the DEF CON wireless. So that's really unstable. At this stage, I do have a MiFi device with me, but if everyone who's like bought a Hack RF today could just not turn it on till I finish the talk, that would be great. Then obviously I need all the code to work. So Marco tweeted at me just now, he said, it's not hacking if it's not spitting exceptions. So I've tried my best. There should be some, hopefully everything works, but we'll see how that goes. Then obviously I'll be using stuff that's online. So all the demos will be on the internet. I'll be using some remote APIs and things. So I need nothing to have changed. So I've made all the sacrifices necessary. But if everyone could, you know, keep their fingers and toes crossed, otherwise you really don't want to see me dance. Okay, so a quick footprinting 101. So if we do a footprint on an organization, I say, okay, I start with a domain, I get DNS names, IP addresses, net blocks, and AS numbers. So if you're using it in the tool, I'm just going to pick, so try and make it a little more interesting. So I pick nsa.gov, and let's say I want to find out, you know, I want to do just a basic forward footprint. So we have a number of transforms that do DNS stuff, like I can do MX, zone transfer, we can look at passive DNS, things like that. And I can find all of those from here. So this is online, this needs to work, yay. There you can see, okay, NSA is hosting their stuff at Akamai. I can find some DNS names, and I get a whole bunch of others, right? So these are like something, NSA.gov, Excalibur, Gary 7, Star Fox, things like this. And then I can say, okay, well, if I look at this model, I go domain DNS, now DNS to IP addresses. So I say, okay, I take all of these and I resolve them to IP addresses. So pretty straightforward stuff, right? And the deal with Maltego is that nothing in the tool is complicated. Nothing that you can run is something that you couldn't figure out by hand or be able to do. But the correlation is what gives you, any sort of capability. So here you can see sort of one DNS name, multiple IPs, pretty straightforward stuff. Or you have two different DNS names on the same IP address. Okay, so what I can do then, I follow it further down. I say, okay, I take the different IP addresses and I just take them to net blocks, natural boundaries. Right, and then I'll take the net blocks to ASs. So, I mean, if you are a pen tester, you can follow this section. You see what I'm doing. I basically really quickly did the forward footprint on, just waiting for those to come back. Right, so there's the net blocks. Take those to AS numbers. And then I have that kind of footprint. And there's nothing really interesting in a forward footprint almost all the time. Like this interesting stuff comes from passive, looking at reverse, finding other things in the net blocks. And I'll show you like as we move to like footprinting people, like where it's more exciting. Okay, and then from the AS numbers, since I don't know any of them, you can take them and say, who's the company owner? I can figure out, okay, this one belongs to Akamai. Okay, so this is like a more interesting one. So some DNS name at NSA.gov resolves to a telnet address, so an internal IP address, probably like a misconfigured DNS name. And then if I, okay, so there you can see, if I look it up, it still has that address. So that's currently live. So Maltego is really, really good at being able to do this quickly. Okay, so that was a basic forward footprint, did that in a few minutes. And then what we did in the tool is we said, okay, well, actually you do this all the time. And we're really lazy, so we try to automate everything we can. So there's a concept of machines, which is the ability to then script basically the way that you'll run stuff so that it goes automatically. Okay, so you can do it with a little bit of code. There's an example of one. And here I can just say, okay, well, this must do everything that I've just done, but in an automated way, right? So then you can do footprints with buttons, okay? Because everyone wants to see it, have it be shiny. So I can say, well, if I start with a domain, let's say do it with NSA again. Okay, instead of running each individual transform, I can just go and say, okay, run a machine. Now I don't have to touch it, and it will then do the whole footprint for me. Right, so it's a really nice way to kind of automate that stuff, so I don't have to do anything for it. And the reason that we have footprinting is so that it can give us information for targeting. Right, so when we start targeting organizations, I can say, hey, this footprint gave me DNS names, domain names, IP addresses, net blocks, so that I can use them when I'm looking for, say, ICS devices, or when you're trying to profile individuals who work at organizations, specifically like more sensitive organizations that we find. So because we were doing, I'm actually going to stop that one. Because the talk will head towards ICS devices in the first section, I was like, okay, well, what are ICS devices that I would be interested in? Okay, so I say, well, Vegas is made up of basically LEDs. Then I look for energy companies in Las Vegas, and the biggest one is Nevada Energy, right? So I was like, okay, well, this is a good place. We're going to find cool stuff on Nevada Energy. So if I do a footprint on Nevada Energy, as nvenergy.com. Okay, I run this footprint. It will go ahead and find all the things I'll then use to start profiling them. Right, so this stuff, if you're a pen tester, is kind of the defaults that you go through if you're doing pen test, especially from outside the organization. Right, so there are all the DNS names. I'll get those to IP addresses and so on. So it's really quick to be able to do this sort of stuff. And basically the takeaway is Maltego is really good for footprinting. Okay, you can do it really quickly. It makes nice graphs. People think you're doing complicated stuff, even if it's really simple. Also, you can do things like, so I see it's listed over there. If I change, I can change the different layouts, and I can change the sizing, so I can see things that are more important in the network, right? So this net block more heavily used than other ones. So if I'm profiling stuff, I can quickly go ahead for that. So once we've done the targeting, then we can say, okay, well, that's our basics. Now we can start looking for exciting stuff. So start looking at industrial control systems. Right, they're pretty basic devices that you have, and they're used to operate and automate your industrial processes. So those are things like power, water, manufacturing, treatment, When you see the car advert being built and it's like, that's ICS devices. And these are systems that are designed to be really reliable, right? They're there to run for 30 years without ever falling over. And of course, you really don't want them to fall over, right? So things go really bad if one sensor, say for water upstream, says, hey, the water is flowing really quickly, and then downstream, they open the dam because they expect more water to arrive there, right? So you don't really want any breakage in this stuff, and really it's a worrying thing. So if you want to hack ICS devices, not what I'm going to cover here at all, but there are just hundreds of different talks, tweets, YouTube videos. I just Googled for it. There's a YouTube video, hacking a PLC with Metasploit. So you can just follow along, click buttons, and be able to compromise the devices, right? But the thing that you find in all of these videos is that actually they have the device with them. So if I go there, they're like, oh, cool, they bought 25 PLCs, they've got them in the lab, they're all IP'd in, and they can own them. But really, if you have to do it as an attacker, and specifically an attacker saying, okay, I'm looking for a really specialized target, like either a specific industry, like I'm going for Nevada Energy, or a particular country, like I want to own all the power plants in wherever, Germany, then you need to figure out, okay, well, how can I find these different devices, right? So that's the first part of the talk that we're looking at. So we did footprinting. I get information on the organization, in this case, Nevada Energy, and then I can say, okay, well, actually these devices, I need to figure out how they're on the internet. And first, if you go, so you can go to one of the Shodan pages, tells you about it. A lot of them have implemented networking, but they basically hacked it onto the actual devices, because these devices are really old for the most part, haven't been really updated as quickly as the rest of security. So there's a couple of major protocols that you'll find, and they're like Modbus, Siemens A7, Niagara Fox, and things that you'll be able to search for. Then of course, if you look through the documentation, right, everyone is like, hey, by default, please firewall these devices, put them in an air-gapped network, make sure they're not on the internet. And everyone should follow the documentation, I guess, but it doesn't really ever happen. So then we can get on to Shodan. So Shodan, basically a search engine for the internet. Actually, the guy who wrote Shodan is here somewhere. And it allows us to search for a particular string. So if I open Shodan, I can search for, I don't know, let's say I was looking for Apache 2.2.2, and it will find all different things on the internet that match Apache 2.2 if I click on search. Hopefully. So here it says, hey, this is a particular machine running that. I can see the different countries. So what I can do is say, okay, well, instead of looking for this sort of stuff, I'm looking for ICS devices. And if I look at this, I can see there's a bunch of different protocols, and each of these kind of has their own spec. So if I take something like, so I just do port 102, so that's for the S7 stuff, if I remember right. So then here I get these results, right? And I look at these results and it says, hey, this is located in Turkey, there's some basic hardware, the firmware version, so things that are on the internet that I can find, right? But remember, we're trying to target something. Like, I don't want to just go and shotgun approach every single ICS device in the world. I want to find specific ones. And most of the time they don't have sort of the information filled in. So I think there will be one, maybe. Yeah, so here's one that says, hey, this one's got a plant identification. It's at the Mauser factory, and it's in Taiwan. Right, so then I could say, okay, well, if I was targeting that, that's really good stuff that I can use. So the first way that we try to do it is to say, okay, well, I can go through all the ICS devices and I can start targeting them. So the idea would be that you could take these ICS devices and let's say you had some vulnerabilities in a couple of them. You would say, okay, well, these are the ones that I'm looking at. And I can basically go and do what I just did, but in the tool. It's not that exciting. So I'll just say port 102. Find me all the ICS IP addresses, right? So any device that matches that, actually, sorry, that's not the right one. So port 102, just on default Shodan. Right, that'll then go and give me that list of however many I've requested. So in this case, 255. But if you were to go through each individual one, so, I mean, for the Siemens stuff, there's like 2,000. But if I take 502 or one of the others, then you'll see that there could be a heck of a lot, right? So there's 13,000. I've got to go through each category. There's like 20 of them. And it'll take a really long time. So hopefully this is going to come back. in the event that it doesn't come back, I do actually have a graph of this. So this one isn't really exciting, so I'll open that graph. Okay, so if I open this graph, it basically says, I search for port 102, I got all these IP addresses out, I can then go and look at them, I can see the results. In here, you get the data segment that says, let me just move this slightly bigger. So it says all the defaults that we found, right? No plant identification. And then I'll say, okay, well, if I'm targeting Nevada Energy, I could say search for the word energy, right down here. I say, fine, there's one device, and it's called new_energy_1. Right, so that may be interesting, but it doesn't say Nevada Energy. So that's the main problem. It doesn't really work, actually, if you're trying to compromise these sort of things. Plus, it's really tedious to do, because I have to go through each individual one. So then, the next thing you said, okay, well, obviously that's a dumb way to do things, right? You're not going to go through each individual thing. You're going to say, well, let's make one way to search for all of them. So kind of like the Google hacking of before, I can say, well, I've got something that I found, I can put it into Shodan, and I can search for all of these different things. So I can search for port 502, I can search for port 102, all of these. So some of these require other stuff like 1962 and PLC. And then I'll be able to say, okay, well, what I can do for a particular organization, I can run this footprint, get a bunch of these details out, and then I'll be able to say, okay, from here, I can go and find the ICS devices, right? So it would be, if I, where's my Nevada Energy graph? Okay, so this one's on Nevada Energy. I could say take these net blocks that I found, let's put that in normal mode. Right, so take these individual net blocks where I found information from the company, I did the footprint, and take all of those, and now run the transform that says, so it says 2 ICS IP addresses. Right, so what that does is it takes every net block, converts it to CIDR for Shodan, and then it will search for each individual port, each individual property that we have that will make these identifiable. Right, and here at the bottom you can see, so I just put the output on so you can see what's there. So it says searching for net colon, whatever the CIDR, every port or source address or whatever else, and you'll see here that you got actually no results. Right, so I got 0 results from everything, which is really lame, because I was like, okay, well, if I'm an organization, it's going to be on their network, right? They've got to secure this stuff. It is, fairly important to their business. So it doesn't actually work either, right? The only thing that's nice about it is that I can start with footprinting information, and I can say, cool, well, I can go from the domain or the network or the IP address, and I can say, okay, I can use that and I can apply it. It does work sometimes, so I did some other footprints when I was playing around with it, and if you take basically any university, right, so their footprint is slightly larger if you look at it on scale, right, but I can find a bunch of different ICS devices from Shodan on there, and I can go and look at them, and you'll see that those are really nicely done. So a lot of the time, they've got good DNS names. They say, this is for backnet. They've got it in the host name, and I can read about it. So they fill in these details, but actually I'm looking to target something more interesting, so this really doesn't work for me either. So at this stage, we're like, well, what other stuff can we do, right? So we can't do it. It's not on their network. We can't just search all ICS devices and hope that someone put in Nevada Energy, because they didn't do that either, if you're wondering. So we say, okay, well, what other kind of stuff can I give Shodan to say, I've got this piece of information, and I want to say, okay, from here, I want to take it to, whatever my ICS devices with all these different things. And one of the things that you can give Shodan is you can give it a GPS coordinate. Okay, so this is really cool because I can say, well, I know some stuff about Nevada Energy, like if I had to look at it, I'll say, I know that they're probably going to be in Las Vegas, right? I want to turn off all the LEDs. I got to get them from Vegas. So what I can do is I can take any sort of point in Vegas. I'm just going to zoom out a bit. All right, so here's all of Las Vegas, and I can say, okay, I pick a point roughly central, and I take the GPS coordinates. Right, so from around here, I can take these GPS coordinates, and I can say, okay, find me IP addresses around these GPS coordinates that match any sort of the ICS devices. So match port 102, backnet, Siemens S7, all of that stuff. And I can put it in a radius. Okay, so in this case, I mean, where is it? It's really huge, right? So I'm going to put in like 50 kilometers. I mean, in miles, that's 10,000. I don't know how to do the conversion. Okay, it's something really big. So hopefully this is going to run, so this will take a while. And then this is then going to Shodan and saying, okay, I've got these points. I can go within a 50-kilometer radius, find any IP addresses. And so they've got a really cool way that they can go from GPS coordinates to IP addresses, which is really tricky, and we'll talk about it just now when you look at doing a sort of country scale attack on this sort of stuff. Now I really need the internet to work with me here. Okay, it's still going. Okay, I've decided this one is taking too long as well. It should come back to us, and I'll probably just switch graph to it, but I have these saved as well. So Las Vegas ICS devices. So here again, we started from GPS coordinates, right? From the GPS coordinates, we found all the different ICS devices for Vegas. Okay, so I'm just going to work with this so we can step through it. Okay, so here, GPS coordinates, all the ICS devices. But actually that doesn't tell me exactly where it is. It just tells me that within 50 kilometers of the central point I picked in Las Vegas, I can find these. So what I want to do is I want to say, okay, well, for all of these different devices, show me exactly where they are, right? So I'm going to select those, and now the other graph came back. See, the demo does work. It just takes really long. But here I can say, okay, I've got these ICS devices, and I'm going to pull out the exact coordinates, right? So I want to see these particular coordinates, and now they're coming back, and that will give me information about it as well. So we'll try to pull up more than just GPS, like stuff that says Desert Toyota, no idea what that means, but that's filled in on the PLC, right? So whatever they have, or whatever kind of device it is, they've got. So that's running there and pulling out all of those. So I could say, okay, well, on my map, this is CCCU, I don't know what it is, I'm just gonna pick a random one. And I can then just put it in, make sure, hey, is this still in Vegas? Is this the right place? So they can see still in Vegas, and hopefully on somewhere near something that's using PLC or ICS device. Maybe it's Shell. I'm not really sure where it is. And we'll look at why this is interesting now. So now I've got all of them. I'm going to say, okay, well, actually, I want to visualize all of these devices, right? Because I'm not going to go through each one like that. That will take me forever. So I'm going to take all the GPS coordinates, all the ICS devices, and I'm just going to send it to a map. Okay, hopefully this loads up. And then I can say, okay, cool. So now I've got a map of all the ICS devices in Las Vegas, and I can go through them and say, hey, what's on this one? Nothing, GPS, great. This one says JCI, I don't know where that stuff is. And remember, we're trying to get Nevada Energy, so what I could do is go through all of them, and because I've cheated before, I actually know where it is. But you could zoom into this one over here, right? And you will see that this one is at Popeye's Louisiana Kitchen, right? Seems unlikely that they'll have an ICS device, but if you look just next door, that's where Nevada Energy is, right? So if you were targeting them, I'd say that's likely to be the ICS device that's sitting at this particular place. So then I can target that and say, hey, there's my target. I can't match it on the other things, but I can find it in this sort of way. So that's really cool to be able to find it, so I can target that particular thing, and then you can see it in the slides. So now I at least get results. Now I at least can find something that says Nevada Energy. That's pretty good. That's how I could do it. But actually, it's kind of manual, and I have to get lucky on it. And mostly because of these coordinate systems, which kind of sucks if I'm doing it in a densely populated area. But actually, if I'm looking to be someone who targets, okay, not just Nevada Energy, I target like all power systems in Poland, right? I decide that actually I'm going to attack Poland today. So in a dense area, that stuff sucks if it's out. But in an unpopulated area, so if I look at something like, actually I have this written down so I don't have to do this. Right, if I look at something like this, so this is a power station in Poland somewhere. If it loads up, there we go. Okay, and if I look at this power station over here, you can see they've got the chimneys with the smoke, so they must make electricity. That's how I know that that works. And I can say, okay, well, if I know that this power station is there, and if you look around it, like there's nothing, right? It's like countryside and no real town. So I'm not actually worried about hitting other ICS devices. So what I can do is I can say, well, let me take a coordinate kind of right in the middle of the power station over here. And then say, well, for these GPS coordinates, let me look for any IP addresses around there. And this time I'm going to take just a radius of 3 kilometers, right? Because actually I could make it bigger because there is nothing else around there. So here I find hopefully some results. So wait for that to return. So there I find two individual, there's an Ethernet IP, both Ethernet IP devices. So I could take these and say, okay, show me the properties of them. So I can pull out that GPS. You see they're both at the same place. And if I go and look at those particular ones, you'll see that it says, hey, these ICS devices are located in this cool field, right? And this field doesn't run a lot of power systems, so it's unlikely that it's going to be in here, but it is, close enough to the power station that I'm looking at that I can argue, okay, that's probably going to be my targets. So if I'm targeting all power stations in a particular place, or in this case just this one, and I know that they're not going to be in the city, then this is okay for me. Like this will work because I can argue that most likely I'm going to be able to get to that. So that way works pretty well. Within a 3 kilometer radius, that worked out fine. But actually, if I wanted to target, in this case, all power plants in Poland, then I'd have to go and Google power plants in Poland. I get a list of them from Wikipedia or something. I'd have to go find them on Google, find all the GPS coordinates, put it all into Maltego, and then I can run with it, right? So that doesn't really work for us. So we were like, well, how can I find all power systems in a particular area? And we found this thing called GeoNames. So GeoNames is a geographical database, and it's really nice because you can look up a place and you get its location. You get GPS coordinates, you put in Eiffel Tower, there you go, GPS coordinates for it. But because it's got a really nice API, we can use it in the reverse way. So they categorize everything by saying either it's tourist spots or things like power station, windmill, hydroelectric plants, things like that. So what I can do is I can say, well, actually, I'm going to start with the categories. And I'm going to say, hey, I'm looking for any categories that match power. Then I'm going to say, okay, from here, show me any devices you have or any GPS coordinates you have that match my category of power in a particular location, right? So I'm using the reverse of it. So if I do that in tool, just over here, everything you can do with the free version as well. Sorry, I'm using the pay for one here. So if I take power and I search for feature codes, so this is what they call it in the tool, then I get out, I don't know, 3 or 4 different ones. So power station, windmill, not sure why it references power, but clearly it does something. Hydroelectric power station. Right, so then I can say, well, from a power station, show me all the locations that you have. And it'll say, okay, well, what country do you want to look that up in? And I can say, in this case, Poland, right? So PL. And then I get all the different power stations, hopefully, for a particular location. So now I've essentially gone and said, okay, well, doing it just this way, I know exactly where every power station is, and now I can start doing the ICS device. So just to sanity check that, I'll pick a random one and hopefully it shows it nicely. So this says that is the Lubin Railway substation. Okay, wherever that is, that hopefully has that chimney that makes the electricity. Okay, now, oh, that was too much. So it's over here, maybe I can street view it. Okay, so middle of Poland, not a lot of streets, not a lot of Google cars have been here. But this is obviously going to be one of the substations, right? I could go through them until I find another one like the one that we saw. So I've got all these coordinates and I've said, okay, so all the power stations, all the ones in Poland, and then I can run that transform that says, okay, find all the ICS devices around here within a 3 kilometer radius. So essentially what I've done is now plotted all the ICS devices in a particular country based on the category, so that if you were targeting them, you could target them all at once, right? You'll say, hey, these are the vulnerabilities I've got. They impact Siemens S7 or 6 or whatever else. And then I can go and start looking at those. So you'll see I didn't get results for all of them. Obviously, they might actually have not put them on the internet or something like that. But these ones I can then find all of them, right? So here's one, this Modbus, Omron, Niagara Fox, things like that. So now I have, okay, all of the different locations, and then this is where you'd go and attack that sort of information, right? So it's really nice to be able to do that, to say, okay, I've got it on a country. So just as a side note on this, the only reason that we have the ability to do this is that we're arguing that the geo to IP stuff works pretty well, right? We're saying if I give you coordinates, you can tell me IP addresses around there. I can scan those IP addresses if they have, the right sort of ICS stuff that's there. So if people ask, hey, is this actually good? Sometimes, right? That's like the best I've got for it. So in denser areas, geo to IP is pretty good, okay? Because the way they work it out is generally they look at like the latency times, and they can say it's likely to be located here based on this. So in less populated areas, it is worse, but most of the time that's okay, because the targets that you're looking at are going to be surrounded by nothing that will impact your search. So if you look at an example of this, so here's an ICS device that says it's in Grey Street 164. So we could say, okay, that's exactly where it is. And then we can say, well, where did we find it? We find it over here. So it's about 300 meters out, which for most part isn't too bad, because you remember if you're doing some sort of attack that says, well, I'm going to grow for, in this case, let's say everything at a harbor, and I end up taking down like the manufacturing plant that's next to the harbor, I'm still going to cause like a whole lot of chaos, and that might be okay for what I'm doing. So it really depends on the type of attacks. But here we're looking at sort of a lot of collateral, especially in the denser areas, if you are doing that. Okay, so that's on ICS devices, right? So we can find interesting places. I can be like, hey, I can find all of them based on the country, or I can look at where they're physically located, and I can find each individual one that I'm looking for. And that gives us interesting infrastructure to target. But what about people? So if I want to look at interesting people who work at interesting places. So I don't care about like people who don't work at like places that don't end in gov or something that I would target, in this case, because I'm an attacker looking for that sort of scale. So breaches happen all the time, right? There's like hundreds of them. There's loads and loads of different data sources that you can use to get these. And everyone kind of does the same audit of it. So they say, hey, are our credit cards in there? Who was involved in this? And you can get like, there's loads of work done on this by like blogs and the white papers and things like this. And actually, I'm just going to use the Ashley Madison as an initial example, and then I'll go from there. So you don't actually need to know this slide. The way that gets into the tool, I use like a bunch of things. They are free, but that's not really that important. This one, essentially what happens with the database is that they've got fields like email address field or the IP address. But if you want to do what we're doing and say, well, we've got a footprint of a net block, and I want to take that to all users that are in there, you have to convert the net block to long and the IP addresses so that you can use it. So some basic fudging of the data to get it to work. So I'm just going to skip that. But basically, if you're looking at it from a forward method, I can say, well, I can go from a domain to a profile, or an email address or an alias to a profile, and that's fairly interesting, maybe. I mean, it's okay. But users, obviously, who work at places that are like more critical, I'd say, you probably shouldn't be in there. So you say, we generally say users don't register work email addresses on places like this. Okay, but if you take something like state.gov, right, because they also denied the visa of the previous guy, I can say, well, if I look at Ashley Madison, there are 34 different accounts there, right? And I can take those accounts and I can take them to email addresses and I can look at the email addresses. So I know that Ashley Madison, the sign-up process is a bit weird, so someone could have signed them up. There are 34 of them, and actually you can take each one to transactions to start looking at how many of these people have paid money, so that you can say, well, that's probably a legitimate account, right? But these are all state.gov accounts, so that's one way that you do it. You just look at those profiles. I can then target those individuals, but not really that exciting. So a way that's way more exciting is to say, well, let me look at the footprinting stuff and say, well, if I know that you work at, let's say, the CIA, right? So that's going to be our example. I say you work at the CIA, then I can do a footprint of the organization, and CIA didn't register, well, not, at least not at CIA.gov. They didn't register any accounts in that database. So I know, okay, I'm not going to find them. But what I do know is I know that I can footprint their organization really well. Okay, so if I take the CIA, let me just do it from here. So take CIA.gov, I run the footprint on it. Okay, that will then go and find all the different results for me so I can look at it. So the idea that I'm looking for here is I'm trying to find, okay, what network space do they have on the internet? Okay, because if I know what network space they have on the internet, I can start looking at that. I realize I started this clock a little bit late. Okay, we're going to skip doing the actual footprint, and I'm going to open it so that we can get to the good stuff. See, I wanted to. Hey, stop. Okay, so here's the CIA footprint. You just have to trust me that it's right. And if I look at it, I've done like the networking side of things. I can find this why is this still running? I can find this particular net block, right? So this net block is interesting to me because most of this stuff sits in it. So I'm going to say, okay, I'm going to work with this net block. And now I've got this net block over here. The first thing I'm going to do, just take it to IP addresses, right? The transform doesn't actually do anything. Where's to IP? Oh, there it was. Okay, so that just says how many IP addresses in that block, pull them out individually so I can work with them. Right, so one of the first things that I generally do is when we do this, so I footprint their organization, I find CIA uses this net block, then I run a transform that says to Wikipedia page edits. Okay, and the reason I want to do that is if you look at a Wikipedia page, you can see you edited it by the history, right? So if you don't have an account, if you have an account, it will say, here's your username. If you don't have an account, it gives you the IP address. So what I can do is I can footprint an organization, figure out their network space, take it to all the IP addresses, and then say from these IP addresses, show me any places that they've been on the internet. Right, and if I find it on Wikipedia, which hopefully will happen very soon, then I can say, okay, I know they edited those, so I actually get a whole bunch of context. So I get firstly that I know that they edited pages, so I know information about the people, right? If someone edited like how to stuff teddy bears, then I know that if I'm going to do a phishing attack, stuffing of teddy bears will be a good topic. So I can see all of these. If I need it validated, I can just see what the pages are. So if I take intelligence, you'll see that here, these are all the pages that they've edited with the word intelligence, right? So if I take, let's look at central intelligence, then I can see what they edited. So here's the difference. They removed the text that said the agency has embassies in every state in the Union and every nation in the world. So someone at the CIA removed that from there. Okay, but more importantly, instead of just these, while I've got these IP addresses and I can see stuff they edit, I know that these are probably their exit nodes, right? They've got a huge network, all the network funnels through these points, and then I can say, hey, these particular nodes are most likely their exit nodes. So now what I can do is I can say, well, if I look at all the breach data, I can say, well, I don't care that they didn't register from, this is CIA. I don't care that they didn't register from CIA, but show me anyone who has an account that came from one of these IP addresses. Because I know if they're browsing the internet, they're probably going through these accounts. So I'm going to take it to the Ashley Madison one. And Ashley Madison is obviously just an example. There's a lot more. Okay, so there's the account. So here I can see that's the account number, and I can take that to an email address. And now I'm going to have to zoom in very quickly. Okay, there we go. So you can see that that is at Gmail. So I don't want to put the address on the screen or whatever. Yeah, so you can go and look it up. It's in the database anyway. Hopefully you figured out how to do it. So that's really interesting for us to be able to say, okay, I can find the exit nodes. I can find people who work at those organizations and their accounts. And this is the example that we just ran through, right? So get the networking, find the exit nodes. So I can see the wiki pages that they edited. So I know those are likely exit nodes. Then I find the profile. Sorry, this is also blurred out. And actually then we'll say, okay, well, let's validate the profile. Let's look it up elsewhere on the internet. And you see something like we found a CV. So same email address, says he works at the CIA, November 2011 is current. And then, of course, we found like worse stuff. So there's like a GitHub account. And on the GitHub account, he has like credentials for Gmail, including his email address, so someone could log into it. And actually, that's probably too much information. Like if we're looking at it, we'll say that profile seems too easy. Like to find that much information about a person is really unlikely, including passwords and things. So it could possibly be a honeypot for them because they know that that data is in there. I mean, we can't say for sure, but obviously there's a lot more than just that one person that you could use. All right, then I think I still have like a few minutes. Then the other thing is that we have some friends at Social Links, and we told them about this idea, and they said, hey, they've got tons of breaches, or they can find it, and they can get us these, they can get us other information about this. So instead of saying, we just looked at Ashley Madison, they said, well, they've got hundreds of them, let's go and use those. And when you do that, I'm just going to show you the graph at the bottom here. You'll see that here's all the different accounts, and obviously those are people who don't register from their work account. So then I can say, well, I can target these individuals outside of when they're at the CIA, right? Because at the CIA, they probably have decent security and stuff, but who knows what it's like at home or other things that I can find. Then you can also take leaked email addresses, look at the headers, and if you apply to the network block, you can see where their SMTP relays are. So then I know, hey, this is the right, I'm just using it to validate the footprint. I can say all of these, or this one IP address has leaked information. So if I take these IP addresses, so from the net block that we found originally, and it's just going to search all emails that were like in leaks, like HB Gary and stuff, so that you can get that sort of stuff out. And one of them does have that in. So I'll show you now. So then, how much time is left? 5. Okay. So then the last section that I want to cover while that's running is that, let's say that we wanted to tie into more individuals. So here we said, okay, we found ICS devices based on location or country, something that I was looking for. Then we found individuals based on their network footprint and how they access the internet. And then what we can do is we can say, well, actually for ICS devices, let's say that I can't get an implant in there, right? Let's say that I can't run my exploit. I need someone to physically go and do it. So what I can do is I can say, well, actually I can try and find people who work there. Okay, and if I can't find it in the organization, like a lot of the places are very sensitive about what's out there, I can try with the one method that I use now with the CIA, or I can do something like this. So Twitter has this great function that's called geo-search, right? Which means that what I can do is I can put in GPS coordinates and I can say, show me anyone that's made a tweet around here. And if I can get that out, I can then start profiling that person, right? So I can see, hey, what did they say around here? So I can use the same method that I did for the ICS devices. I can say, okay, I find interesting locations, like I find all power plants. Actually, let's do it quickly. So I say, start with the phrase, power, oh, I'm going to stop this quickly. Okay, start with power. I find all the feature codes. So, what matches power? I say all power stations. I'll pick, okay, I'm just going to pick Poland again. Right? I find GPS coordinates for every power station that they know about in Poland, and then I can say from here, take it to people who have tweeted around these, right? So what is that? 2 tweets from GPS. Okay, and I can give it like a 1 kilometer radius. And then I'm looking for any individuals that have been there. They've tweeted from the parking lot, going home, whatever, excited for beer. And then I can say, okay, well, now I can profile these people, right? So here, see our latest something, job, click. And I can look at, it came from this particular IP address, and I can then say, where was that actually physically found? And then I can look it up and say, okay, this is close enough to the power station that I can assume that this is where this person works, right? So I'm just picking a random one. I don't know how well it will work. But there should be a power station around here, and then I can see, hey, this is the individual marker where they tweeted from. So if I start tracking that person, I'll see, okay, maybe there's things from work, or maybe there's stuff at home. Okay, so just to do the conclusions, if you're looking for ICS devices on the internet, they're really, really difficult to attribute. Okay, so you can't, like no one puts in, this is where it is, this is the plant, anything like that. They're usually not on the corporate networks, unless they are not visible to the internet. So they could all be firewalled off. Obviously then I can't see it, so I don't know. But they're a lot easier to find on GPS, even if it's more of a manual process for an individual target. And if you're looking at doing it on a large sector, like targeting the harbor or a particular power plant, then you know that you're going to accept collateral damage, right? That geo to IP stuff is not as accurate as you'd want it to be. So you might end up being like, okay, I target all the things around it. Then if you look at the breach data, it gives us a lot of information on the people and organizations. So first I find exit nodes. I can validate those, that's where they come from an organization. So as a pen tester, you would maybe target those because they have both internal and external access. Then you also find the private email addresses, right? So I can say, hey, cool, I can go from someone who works at a particular target, find their network space, find the accounts they're registered with, and say, cool, now I've got their Gmail or whatever, I can look it up on Facebook or whatever else, and then have the ability to go and target those individuals privately outside their organization. Okay, so thanks for coming to the talk. If anyone has questions, I think I have to meet in the corridor. But I'm Andrew Mock on Twitter or andrew@pitserver.com. Cool, thanks.